We're on Zoom. Do you have lunchtime? Can you guys hear me?
Yep.
Yes.
Yes.
Outstanding. All right, so happy snowstorm, everybody. I don't know about you guys, but I'm working from home today, so I'll have a limited range of motion. I like to move a lot during lecture, but I'll try to keep it on camera. Today, I want to talk about what I think is the most important part of understanding manufacturing in manufacturing engineering, and that's understanding what quality is in manufacturing. If you can't understand this, then you'll never be able to successfully operate a manufacturing company and successfully be a manufacturer. So I think I'm sharing the screen now. Is that true?
Yes.
Perfect. All right. I want to ask you guys a question, and I think you can respond in the participants window. If you open up the participants thing here, you've got a few things that you can do, right? You could say yes or no. Is that a thing there?
Yep.
Yeah.
All right. You can say yes or no, and you could raise your hand, right? I think those are the three things that you could do.
Yeah.
Yep.
Perfect. It used to show me that at the bottom of the screen, but now it shows me what you selected, but it doesn't show me what your options are. All right, so I'm going to go to the next slide, I think. All right, and so I want to do a little poll here with answering the question, which car manufacturer offers the highest quality? And so your choices are Mercedes, Chevrolet, and Kia. So between these three car manufacturers, I want you to tell me which one offers the highest quality. If you think it's Mercedes, say yes. If you think it's Kia, say no. And if you think it's Chevrolet, raise your hand. And I think that should give us the all right. So I got 5, 6, 7 people with their hands raised. 15, 14, 13. People are changing their mind here. So we're really a lot of people are changing their mind. So if you think it's Mercedes, say yes. If you think it's Kia, say no. And if you think it's Chevrolet, raise your hand.
Professor, the yeses and the nos will automatically go down after 5 seconds.
That didn't used to happen.
It's a new update thing.
I don't think it's an update. I think it's a bug. All right.
I agree.
All right, let's go to the all right, how am I going to do this then? That's how I did it last time and it worked really well. 5 seconds for yes and no. That's ridiculous. But the hand thing goes, all right. So everybody, if you think it's Mercedes, put your hands up and we'll count to 6 seconds or so. You got 6 seconds to put your hand up if you think it's Mercedes. 1, 2, 3, 4, 5. I don't know, 6. So I get about 21 people think it's Mercedes. All right, so put your hands down. I'll write this down, 21. And if you think it's Chevrolet, raise your hand now. So I had Mercedes at 21 people. What do we got for Chevrolet? This works. I used to, if we do this in the classroom, I have people stand in different parts of the classroom. And they stand in groups, and then the amoeba mob. So I get 15 of you think it is Chevrolet. All right, and if you think it's Kia, raise your hand. I did try to bias this a little bit, right? I did post a picture of a $150,000 Mercedes, and then an average Kia and an average Chevrolet. All right, so I get 9 of you picked Kia. All right, and if you abstained, raise your hand. Put your hands down first. Really? I get one person raised their hand. They said they abstained. Charlie, why'd you abstain? Oh, somebody that abstained. Why did you abstain? Nobody wants to tell me. All right, that's fine. It's fair to decide that you don't have an opinion on some of these questions. 21 people think Mercedes is the best. Somebody that picked Mercedes, tell me why. Highest quality. This is the problem. When it's had all the yeses and the nos, I could call people by name. Somebody that picked Mercedes, tell me why you picked Mercedes.
I picked Mercedes because I think they generally cost the most compared to the other two brands.
All right. So I don't know who was talking, but he said that we think Mercedes generally costs the most, and you must pay for quality, right? So you get what you pay for, and I often believe that is true. You do get something extra when you buy the more expensive thing. I have that personal feeling too. Somebody who picked Kia, tell me why.
For me, the reason I picked Kia is it's the Asian engineering for the cars. It's yes, the Mercedes is German engineering and all of that, but if I'm going to sink a lot of money into a vehicle or into something that's going to be hemorrhaging later on, I'm going to do it to a boat. So, yeah.
So if I want to waste money on something, it's going to be a boat. Therefore, I'll get the Kia, so I'll have more money to pay for my boat. I like that attitude. And somebody who picked Chevrolet, why'd you pick that?
I picked Chevrolet just because it seems like its reputation is for being reliable and durable and lasting a long time. So that seemed.
Out of curiosity, what kind of car does your father drive?
He drives a BMW.
Oh, okay. See, my dad was a Chevy guy, and so we always had Chevy trucks at our house, except when his company would get him a company car that wasn't a Chevy. So I mean, my parents will continually buy the Chevy, and I don't think they consider whether or not it's the highest quality or not. They're just Chevrolet people, and so there's brand loyalty there. So see if my presentation works, and I can go to the next slide. Oh, almost. I think I got to click up here. All right. So in 2017, JD Power did a study of initial quality. They found that Kia, of all the cars they looked at, had the highest initial quality. That Chevy was somewhere in the middle, and that Mercedes-Benz was at the bottom of the list. Who wants to comment on this?
I think it's because a lot of Mercedes parts and a lot of German cars in general are extremely over-engineered. So you have a lot of complex electronic systems that are almost like deemed to fail after a certain amount of time. While if you look on the Kia commercials, for example, you have like a 10,000, or it was like 10-year warranty. So obviously the quality of manufacturing must be to a greater degree there.
So you're, and I really like that discussion. Anybody else want to add to that?
Wait, but so for the ranking on the right, so probably per 100 vehicle. For Mercedes-Benz, it's a two problem.
So yeah, it cuts off the first line. It's 102.
Oh.
Yeah.
Okay.
When I converted the picture from PowerPoint to Google Slides, it slid it over a little bit, but that's actually 102.
Okay. Yeah, no, for the Mercedes, it's definitely with the problem with the tanks in World War II, where they just had their German tanks were just way too complex. Yeah, I could see why you'd have that problem with the cars.
So there's a significant amount of complexity in the Mercedes that's missing in the Kia, or not. Missing is the wrong word, right? It's not there. And then where's the Chevy come in? Somewhere in the middle. Chevrolet, a little bit, just below BMW to the Chevy guy that's got the BMW driving dad. So, but what do we really know based on this graph?
Price isn't, you're not always paying for quality.
You're
paying for luxury.
What do we really know about this graph? We know that JD Power reported that they asked car dealers, how many problems did your customers report with their new car? Right, because this is initial quality, so they're talking in the first year of ownership. So we know what the car dealers reported to JD Power. We're going to assume that JD Power didn't fudge the data and that they're actually telling us what they learned. So we know that JD Power talked to car dealerships. The car dealerships have told us these are the number of problems reported per 100 cars. Is it possible that Kia doesn't have the same customer as Mercedes-Benz?
Yes.
Is it possible that the person that spent $150,000 on the Mercedes is more likely to complain if something isn't perfect?
Oh, yeah.
Yes.
Yeah.
Could it also have to do with dealership service?
Is
That
it
seems to-
possible that the Mercedes people kept better records than the Kia people did? I don't know. So there's a couple things I wanted to say here. So we had different opinions from what JD Power said. We had different understandings internally ourselves about what it means to have quality, right? And that's normal. When we use the word quality in daily speech, it means different things at different points in the sentence, right? That was let's see. What's a good example of that besides the car thing here? I got a quality workout this morning moving the snowblower around. Right? What kind of quality was that, right? Was it a good quality? Was it a bad quality? Was it my shoulders sore? Was it I should have hired somebody to plow the snow kind of quality? So when we talk about quality, sometimes, well, quality is in the eye of the beholder. Would you agree with that? Raise your hand if you agree that quality is in the eye of the beholder. Just like beauty. I like the hand raising thing. At least 40 of you raised your hand and said quality is in the eye of the beholder. Okay, and I think that is true when we're talking in general, when we're talking to our friends, when we're talking to our parents. That statement is true. Quality is in the eye of the beholder. What does quality in manufacturing mean, though? Because if we're going to be engineers, especially if we're going to be manufacturing engineers, can you guys hear my kids screaming?
Yes.
Sounds like somebody's about to die. I think they must be on recess now for homeschooling. What is this thing that we call quality? If we're going to talk about quality in manufacturing, then we need to define it more precisely. Otherwise, we'll all be hunting for something different when we're trying to create quality. So call out. I'm going to type in some stuff here on the slide. You guys can still see the slide now. It's just not.
Yeah.
Yeah. All right. I'm going to type in some stuff. Call out what you think it means to have quality in manufacturing.
A part
Being-
that does its job.
So does its job.
Longevity.
Being able,
I got longevity.
Consistent tolerances.
Consistent tolerances.
Durability.
Durability. You'll notice I can't spell well. That's okay. The internet fixed it. So something that always does its job. It lasts a long time. It has consistent tolerances. There's durability, which I think means lasts a long time, right?
easy to replicate.
Easy to replicate. Anything else that comes to mind?
Not
I would say
super
like
expensive.
I guess that was a lot of stuff that came to mind. Now try it one at a time. That works in the classroom, but when it's digital, it doesn't work. Try again.
Serviceability.
Serviceability. Who else?
Easy maintenance.
All right, that's enough for this list. What are all of these things that we've got on the list? What do they have in common?
User friendly. Like it has to do with the use of the part, I guess.
So it's user friendly. I think what these things all have in common is they're all attributes of a product that we may want to pay for. Right? So manufacturing is making stuff people want to buy. Right? So our definition of quality should have something to do with making stuff people want to buy if it's quality for manufacturing. Does this list seem like attributes that we would like to have in products that we buy? If you buy something,
Yes.
yes.
job, right?
Absolutely.
You want it to last as long as you need it. You want it, if you need to buy more and more of them, you want them all to be the same. Again, this durability is sort of longevity. It's the same thing. Easy to replicate. Maybe that's not as important to the customer as it is to the manufacturer, but it's probably important to the manufacturer. Serviceability, especially for us engineers that like to take stuff apart to see what's inside. We like it when our stuff is serviceable so that it's possible to take it apart, look at it, put it back together. Same thing, easy maintenance, user friendly. These are all sort of attributes that the customer might want. Now, if you're the customer and you're buying a bomb disposal robot, and the way your particular bomb disposal robot works is it drives on some little tank treads over to where the bomb is, and then it detonates a high explosive to destroy the bomb. How long does it have to last?
Once.
For training and the drive up to the bomb.
Right. It's got to have one instance of use, right? Hopefully.
Well, training too.
Well, all right. So you got to practice, but you don't necessarily have to practice with the one that you blow up. But I'll agree that you do need to practice driving up to the bomb. So I got a chance to, raise your hands if you're a NASCAR fan. I got one person that says no. Really, not a lot of NASCAR fans here? A few of them popping up. All right, a few people. But you guys know what NASCAR is, right? If you like any kind of auto sports, raise your hand. It doesn't have to be NASCAR. All right, that's better. So I got a chance to visit Hendrick Motorsports a few years ago. And we're walking through. Did you know that Hendrick Motorsports partners with Haas Automation? And Haas Automation is the company that we get our CNC machine tools from at WPI. So Hendrick Motorsports has a machine shop full of Haas machines, a giant machine shop full of Haas machines. And Hendrick Motorsports doesn't just make engines for their cars. They also make engines for several other race teams. So they're manufacturing these V8 piston engines for NASCAR teams all day long, every day. As we were walking through, they were doing some finishing operations on the pistons for one of the engines at one of the machines where we stopped to talk to the machine operator. And one of the guys I was with, he says, "What's the design life of one of these engines?" So what do you think the design life is for a NASCAR engine?
500
One
laps.
season, 1 or 2 seasons, maybe.
500 laps.
Race time?
He said 500 miles.
It's just immediately after the checkered
The
flag.
longest race they take is 500 miles. So designing an engine that would last for 10,000 miles even would be wasteful because the customer doesn't need an engine that lasts for 10,000 miles. So I'm going to say that quality in manufacturing actually means one thing. It means giving the customer what the customer needs when they need it. And all of the things that we listed here in what is quality might be things that the customer needs. But if we want to truly give quality in manufacturing as giving the customer, let me write that down. Giving. And if you can consistently do that as a manufacturing company, if you can consistently give the customer what they need when they need it, then you will succeed as a manufacturing company. I tend to add, but I think it's an aside, you need to be able to do it at a price point that the customer can afford. And that's where we talk about, when we met last time, we talked about this whole idea that manufacturers making stuff customers want to buy. We know that the customer wants to buy it because they bought it from us. Up until the customer buys it, we only think they want to buy it. And that we want to stay in business by having a positive profit rate. Right? That was basically what the first lecture said. The way we're going to have a positive profit rate is if our customers continue to buy the things that we want, that we make. And so in order to do that, we need to be able to make it at a cost so that the price we give the customer is something that the customer can live with. Does that make sense? Now we can all go start our manufacturing companies. So
Yes.
Quality in manufacturing is giving the customer what they want when they want it, or what they need when they need it. I think it's giving them what they need, not necessarily what they say they want, because the customer might be wrong. And if you give the customer what they want and it isn't what they needed, then the customer may fail. And I think we have some obligation to our customers to make sure that they succeed also as manufacturers. All right, so that's quality. Today, I said we were going to talk about quality in high mix manufacturing. What do you think I mean when I say high mix manufacturing? I'm going to add a slide. What is high mix manufacturing?
Manufacturing that involves multiple inputs of different components, and you're assembling the final product.
No. Well, how about mass production or high volume manufacturing? What's mass production mean to you?
Producing large amounts of items for as cheap as possible while still
Producing
delivering a
large amount
product.
of items as cheap as possible, or does it, in its essence, does it really just mean making a high volume of something? You don't necessarily have to have lots of different products as long as you sell enough of the product that you're making.
Yeah.
So it's and it was guys like Ford, right? Ford created his assembly line. His goal was to be able to make cars so that he could sell them at a price point that the people who worked on his assembly line could afford to buy them. So he figured out this way to do this mass production of automobiles. Now, there was a lot of components. There was a lot of different components that had to get put together in order to make each automobile. But Ford's product was the automobile. So Ford was not a high mix manufacturer. Ford was making cars. Now, some of the people supplying parts to Ford may be high mix manufacturers, but a high mix manufacturer is somebody, and another way to look at it often we'll call these kind of companies job shops. And so they're a manufacturing company that make small production runs for other customers. So for other businesses, usually. So small production runs of parts for other businesses that are then going to use those parts to maybe put them inside an assembly. And then that assembly may get shipped to another manufacturer who's going to then use that assembly and put it inside their product, which they sell to the end consumer. So and a lot of this has come up. The automotive industry is a huge example of this. The aerospace and defense industries are similar to this. But what the low mix kind of manufacturers, the people that are like Ford's and Chrysler, they may have a bunch of different models, but they're not really doing high mix manufacturing because they're not making those different models on the same assembly line. Usually, there's some exceptions. Toyota does some crossover stuff, but they'll build a plant that makes, I don't know, the Ford Fusion. They've got a plant that makes the Ford Fusions, and they've got a plant that makes F-150s. And those things, but they may put those plants co-located, but the assembly line is unique. But there's components coming in to that assembly line so that the workers at Ford can assemble the vehicles. I don't know why I picked Ford this time, but so that high mix manufacturer or a job shop often doesn't know more than about a week in advance what parts they're going to be making. And they may have 10 or 20 different core customers that are ordering parts from them. And one of the things that they have to be able to do is they have to be able to quickly switch from making, what do I got? Nothing. They may have to quickly switch from making squishies to making screwdrivers, to making dice, and they need to switch their process over from part to part. From the Worcester Public Schools are calling to tell me that I can't go pick up my free school lunch today because their distribution center is closed, I'm guessing. But we knew that because they called and told us that last night. I got people with raised hands. Is that?
Yeah.
Did you raise your hand because you wanted to talk, Kevin? Or Charlie? Or did you? Just
Yeah,
fall
like in
asleep?
all Apple products, they have a lot of Samsung chips in them. Samsung does all the processing stuff for Apple, and it all goes to the Apple factory and it gets assembled there.
That's cool. I didn't know that, but it makes a lot of sense. And is Samsung factory actually making those chips, or is it just a Samsung design that somebody else is making? And could be that too. I don't know.
Yeah, I don't know.
I actually do have a good story about the iPhone, but it doesn't really fit this lecture, so I'll tell that story another time. I'm trying. I was this weekend as I was getting ready for this week in classes. I was actually listening and watching some of the videos of some of my past lectures, and I found myself as I was watching the lecture wishing that the guy would just get to the point and say the important stuff. So I'm going to try to stay more on topic. I tend to try to be a storyteller, like this moment right now where I'm telling a story about what happened on the weekend. But I'll try to keep my stories focused on topic of the lecture or keep them very short like this one just was. So high mix manufacturing companies are manufacturing companies that change from part to part very frequently. They make a low production volume. And by low production volume, it might be 1,000 or 10,000 parts, but it's not 10,000 parts a day of the same thing. And so that tends to be a high mix manufacturing company, and they work differently from the low mix or high volume manufacturing companies. So we're going to talk about that on Thursday this week. It's almost like a difference between specialty production and mass production. So if you think of it, I think you've got the image. Another way that people talk about this, and a lot of learning to be an engineer is about learning the words that engineers use. I don't know if you've experienced that yet, but a lot of what we need to do is we need to be able to communicate with each other in the secret language that engineers have figured out. And so another thing that we'll hear talked about when we talk about these kind of companies is you might have a tier 1 company or a tier 2 or a tier 3 company. I suppose there could be an unlimited number of tiers. And so what a tier 1 company is that's like the Ford or the Boeing or the Toyota. That's the company that actually assembles the finished product and sells it to the end customer. That's tier 1. A tier 2 is the people that supply stuff directly to them. Tier 3 supplies stuff to tier 2 companies, and then you get the picture. So you can talk about tiers in manufacturing, and that's what we talk about. So high mix just means don't always make the same part. If you don't always make the same parts, you might often be making prototypes. And we are going to talk a lot about prototypes and prototype manufacturing next week. But I think you guys all have some idea of what prototypes are. And that's primarily what we do in the WPI machine shop is we help people make prototypes. So high mix manufacturers don't always make the same kind of parts. How do you know wait, where'd it go? This one. If we want to give the customer what they need when they need it, and we're not always making the same kind of parts, how do we know that we're giving the customer what they need when they need it?
Did you look into like the buying patterns?
You could look into buying patterns. That tends to be more the kind of thing that tier 1 businesses do when they're deciding what their new products are going to be. We're more talking about you've made your UFO squishy. You're about to put it in the box and send it to my daughter so that she can give it to me as a present. But you want to make sure that she's going to accept delivery of it. So how do you know that you're going to give the customer what they needed?
By getting half of, oh, sorry.
I was trying to send a sample before send the entire shipment.
You could send a sample before you send the entire shipment. And I suppose with something like squishies, that might work. But what do you, what, say again?
Wouldn't one possible method be to know your tolerances? So if you have a piece that you say you need to manufacture, it has specific specifications that you need to get to, like measurements and dimensions, and then you have acceptable variations on that. So you need to know what you can, basically where your wiggle room is.
Getting a down payment.
So that might be good business sense to make sure that you're going to get paid no matter what. However, if they pay you in advance and then you fail to deliver what you told them you were going to deliver, they're likely to sue you. And if you can afford more lawyers than they can afford, then you're going to win the lawsuit. I wasn't paying attention to who was speaking, but somebody was talking about tolerances and specifications and measurements and the variations are the tolerances. This would be really cool if I could just click that word and drag it up here now. Unfortunately, I can't do that. But let's do this. And specifications really belongs above tolerances. It's so much more fun on a whiteboard running around in front of you guys. And so what are specifications?
I'd say specifications are probably things like material, finish.
So specifications are things like materials. When you said finish, you meant like surface roughness, surface finish?
Surface finish, or like possibly even painting and things like that.
The product being able to take certain stresses.
Its ability to withstand stress. So that's strength, I guess.
Wouldn't that be a tolerance?
So a tolerance is, that wasn't what I wanted to do. A tolerance is applied to a specification, and the specifications are the things that the designer has chosen. So I'll call these specifications or design parameters. Design parameters. And those are the things that the designer has decided will allow you to make a part that they can then sell to their customer, and it will fulfill whatever their customer's need is. And so the designer has said it needs to be made out of this material. It needs to have this color paint with this certain surface finish on the paint. So this amount of shininess on the paint. It needs to have a certain strength, although really that strength often comes from the material specification. So typically at the I'm not going to say at the manufacturing site you don't measure strengths, because some of the manufacturing processes that we do either make materials stronger or less strong. But the specifications are the things that the designer has decided will allow the part to fulfill their customer's need. The tolerances are how much the designer is willing to let the manufacturer screw up when they're making the thing to meet the specifications, so that, well, the designers understand that nobody's perfect, that the manufacturers will have some variation from part to part and within the part in their ability to meet the specifications. So another big specification is things like distances and size and geometry and things like that. Those are all specifications. Tolerances are the variations the designer is willing to let the manufacturer take. So if we have specifications with tolerances and we design our manufacturing process to make the part, and so those, wrong slide, those tolerances and variations in these variations, that's sort of the wiggle room that we have with our ability to make the part without screwing up. You also said measurements, right? So is it really the measurements that tell us whether or not we've met the specifications? So if we want to meet the customer, if we're a tier, say we're a tier 3, tier 2, tier 3 manufacturer, so we're not the designer, we haven't designed the part. Somebody's got their hand up. R, did you want to say something? Nope. Okay, must be a remnant hand. Okay, so as we work as manufacturers, we don't want to ship crap to the customer. Is that acceptable? And to avoid shipping crap to the customer, we can measure the parts to make sure that they're within the tolerances on the specifications. Anybody know what we call that?
Does it have to do with like defects, like they have in like Six Sigma, like lean manufacturing? Like you have to.
We are gonna
like
talk
minimize
about
defects.
that we're gonna talk about that stuff on Thursday, because that I'm not gonna say it doesn't apply to the high mix manufacturers, but it applies much more strictly to the high volume manufacturers. But what we're doing when we take our measurements is we're doing inspection of the parts. The first inspection we do is we look at it. We say, oh, yeah, that part looks like the right part. That is a step along the way. That's a visual inspection. Then if we had dimensions, say our part had 2 holes in it and they had to be a specific distance apart for the part to function. So then we measure the distance between those 2 holes. And if they're within the tolerance, then that's another step to say that's a good part, right? So we do inspection and quality control or quality assurance. And so these are the steps that we can take to make sure that we don't ship crap to the customer. Now, what's profit again?
Value minus cost.
Value minus cost.
Value minus cost, right? And profit rates value minus cost over time. So if we want to keep our profit rate positive, the important factors are the value. So that's what the value is, the cost that the customer is willing to pay for, right? Cost so what's the and time? So value is what the customer wants to pay for. What are the things that factor into the cost and the time that it takes to manufacture something?
Labor.
All right, so we've got a cost of, come on. Labor.
Materials.
Materials.
Number of
Facilities.
operations.
So facilities. So I think the number of operations just makes the labor cost more, right?
Or I was thinking more for time. Just like
So
getting
the
a machine set up and everything.
yeah, so big factors in time are number of operations, number of setups, and so a setup in manufacturing, it's especially important in high mix manufacturing, is how many different directions do you need to hold on to the part in order to make the part? And so that's how many setups there are, roughly speaking. So number of operations, number of setups, the time it takes to do the operations, right? The time it takes to do the operations. And of course, all of these time things act on labor, act on the cost of labor. Cost of the materials, the cost of the facilities is also impacted by all of these time things. What about inspection? So our quality inspection adds cost to the part. Does the quality inspection add value to the part?
Yeah, if you have a higher quality, you probably can charge more for it.
But the customer has already decided what they're willing to pay for the value that they have requested, for the part that they have requested. So does the fact that we made sure that it wasn't crap actually add value to the part?
I'd say that kind of depends. If you're hitting really, 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 really extremely tight tolerances, then yes.
So, all right, I'm going to agree with you that you can't make the part without doing the quality inspection, especially if they're really, 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 really super tight tolerances. One really was probably enough, but I know what you mean. I'll agree with you. You can't make the part without inspection if the tolerances are tight. But does it add value to the part?
Does it add value to the future parts? Because if your company like has a good reputation of always having high quality because you do
It adds
well-
value to the, it probably adds value to the company, but I don't think it adds value to the part, with one exception. So the customer doesn't care if you do the inspection. They simply want the part to be correct. Unless the customer is willing to pay you extra because the part comes with an inspection certificate. If the customer is willing to pay extra because you did the inspection, then the inspection adds value. Otherwise, the inspection simply adds cost. I'm not saying it's a cost we can get rid of, but it's a cost. And so the cheaper we can do that inspection, the better it is. All right, does inspection add value? I'm looking at my notes here to make sure I don't miss anything I said I wanted to talk about today. And the last thing on my notes for today was, does the inspection add value? I'm going to say that the fact that we do the inspection probably adds value to the company, and that kind of value is called goodwill. Because if we have a reputation of never shipping bad parts, customers are going to want to order more from us. So it adds value to the company, but it doesn't add value to the individual parts. At the part scale, it simply adds cost. And the value, remember, is what the customers are willing to pay for. So if the customer is willing to pay for an inspection certificate, then that inspection does add value. And that's sort of in high mix manufacturing now. We're making different parts all of the time. The first step usually is to look at the customer's design, figure out if you as the manufacturer understand what the customer wants. Tell the customer how much you're going to charge them to make it. And then you'll design your manufacturing processes and your inspection processes so that you can make it for less than you told the customer that you were going to charge them, assuming the customer said, yes, I'll pay that much for it. So these high mix manufacturing, these guys are doing this every day, all day long. Some of these guys may be quoting 20 jobs a day that are coming in for setting up work for 2 weeks from now. And so that's sort of the idea in quality in this high mix manufacturing is you've got to always make sure you give the customer what they need. You've got to do enough inspection to ensure that you're not giving the customer crap. And you got to do it over and over again on different parts all the time. I'm going to give you a little bit of a sort of a homework assignment for next Thursday. So tomorrow we're going to focus on lab stuff, and about half of you, I think, now have had your first opportunity to get on Zoom with your PLAs. And the objectives in the lab this week are to make sure that you get the CAM software installed or you get access to it on that Nutanix frame. If you're still having trouble with that tomorrow, we're gonna start the lecture all together, and then we'll go into breakout rooms with the PLAs for your lab section. So make sure that you get that settled by the end of the lecture tomorrow, for making sure that you've got access to a spree. And before we meet on Thursday, I would like you to do a little Google search, and I would like you to understand what the ISO is. So ISO. And understand what it means to be ISO 9000 certified. So this is a certification that manufacturing companies can get. And I'd like you to have researched what it means. So you don't have to know all the steps about how to get it, but research what it means to be ISO certified. And then we're going to talk about ISO and standards and things like lean manufacturing and Six Sigma and tools that impact part quality when you're doing that high volume manufacturing. on Thursday. So thank you guys for being here. That's what I have for today. And look at that, I ended right on time. Woo. But I'll stick around if anybody has any questions. I'll go ahead and stop the
Thank you, Professor.
Thank you.
Bye-bye.
here.
Thank you.
Thank you.
Thank you.
Thank you, Professor.
Thank you.
Professor.